Hi, Assalamualaikum and a very good morning, everyone. So today we are going to continue with our chapter 7, Ionic Equilibria, with our new subtopic 7.2, acid-base titration. So there are a few learning outcomes that we are going to cover for today. The first one, we are going to describe the titration process. Second one, we are going to distinguish between the endpoint and equivalence point. Third one, we are going to sketch and interpret the variation of pH against titer volume for titrations between strong acid and strong base, strong acid and weak acid and strong base. And lastly, we are going to identify the suitable indicators for the acid-base titration. So, firstly, we are going to look at what is the definition of acid-base titration. So acid-base titration is basically a procedure for determining the volume of two solution, acid and base, which will exactly neutralize one another. And by using a solution known concentration, which is standard solution, the concentration of another solution can be determined. So this is how you set up your titration experiment. Okay, where inside the burette is the titrant, okay, where you're going to titrate the titrant inside the analyte. So inside the conical flask is the analyte. Okay, so let's look at how the titration process occurs. Okay, so the titration process is between the titrant and the analyte, where you are going to add the titrant drop by drop into the analyte. So the titrant and the analyte can be acid or base. So if your titrant is the base, then your analyte is an acid. But if your titrant is an acid, then your analyte is a base. Okay, so inside your analyte, you will add indicator so that you can see the endpoint, so that you can know the color change when it reach the endpoint. Okay, so let's look at what is the point that we're going to discuss in the titration process. So there are 2 points that is significant in this titration process. The first one is equivalence point and the second one is the end point. So what is the equivalence point? So the equivalence point is the point where the amount of acid and base has mixed stoichiometrically equivalent. Okay, maksudnya the number of mole of acid is equal to the number of mole of a base. Okay, and what is endpoint? So endpoint is actually where the indicator color will change. Okay, from acid to base or from base to acid. Okay, depends on the analyte and the titrant lah. Okay, so now we are going to look at the types of acid-base titration. So there are 3 types of acid-base titration. So the first one is between the strong acid and strong base titration. Second one is strong acid and weak base titration. And the third one is the weak acid strong base titration. So here we are going to learn about titration curves, where these titration curves actually explain to you the variation of pH during the titration process. Okay, let's look at the first types of titration, which is strong acid and strong base titration. For example, here we have between the hydrochloric acid and sodium hydroxide, or between the sulfuric acid and the sodium hydroxide, and many more. Okay, so let's look at the first curve where the titrant is the strong base and the analyte is the strong acid. So maksudnya dalam conical flask is a strong acid and dalam burette is a strong base. Okay. Alright. So maksudnya dekat sini. Oops. I just in case like some of you cannot visualize it. Okay. Wow. Okay. So inside here is the acid. Contohnya acid. And dekat burette ni. Okay. Burette ni adalah base. Okay. Dia akan titik sikit lah. Okay. Alright. So this is the titration between. So this is the analyte. Acid is the analyte. And the titrant is the base. Okay. Contoh macam ni. Alright. So now. Okay. Let's go. So. Kiranya pada asalnya, pH dia akan jadi strong acid. Oh, okay. Before that, I'm sorry. What is what we call it, component inside the titration curve? So we have to do the x-axis and y-axis pH against the volume added. So kalau titration kita base, so kat sini volume base added. Kalau titration kita acid, so dekat sini volume acid added. So since our titration now is strong base, so dekat sini the volume base added. Okay, then we are going to label the pH 7 and 14 so that we can do it, so we use it as the indicator lah. Kita boleh nampak dia macam, kalau nak lukis graf tu tak ada lari kan. Okay, so kat sini kita we start at the beginning of the curve of the titration. Is dekat bawah ni because it is strong acid, it has a very low pH value indicating that there is a high concentration of hydrogen ion which is completely dissociated from the strong acid. Okay, alright, so dekat sini, dekat point sini initial pH dia strong acid. Okay, dekat point sini, excuse me, so dekat point sini nampak tak dia nak rise slowly dekat sini. So dekat sini the pH increases gradually. Okay, as acid is now neutralized by the added base. So dekat sini titration strong base dah mula drop wise masuk dekat dalam analyte. Okay, bila sampai equivalence point dekat sini, so this is the equivalence point. So when the reaction is between the strong base and strong acid, the equivalence point excuse me, is pH equals to 7. Okay, so now, so sekarang kita dah dekat point sini. So dekat point sini, the pH will rise slowly until it completely dissociate. Okay, until the base completely dissociate. Okay, so dekat sini dia dah reach end point. Maksudnya kat sini color dia dah berubah. The color punya indicator dah berubah. Maksudnya dia dah fully neutralized. Okay, dah habis dah dia punya neutralization process dia. Okay, so this is how you draw or sketch your titration curve when the titrant is strong base and the analyte is the strong acid. Okay, ni between strong acid and strong base titration lah. Okay, so what happened? Okay, so apa kalau kita terbalikkan? Kita jadikan titrant kita strong acid, analyte kita pula strong base. So maksudnya yang dekat dalam conical flask tu adalah strong base. Initial dia mesti pH tinggi, betul tak? Sebab strong base has high pH. And the titrant yang dekat dalam burette tu adalah strong acid. So dekat sini kita akan lukis curve kita. At dekat sini is the initial pH of the strong base. Okay, so dekat sini kita punya pH kita tinggi sebab asalnya base. Betul tak? Strong base. Okay, lama kelamaan dia dah start gradually fall. So indicate yang dia dah start neutralize with the added hydrochloric acid contohnya ataupun acid. So dekat sini dia dah sampai equivalence point where the amount of acid is equal to the amount of base stoichiometrically. Okay. So now bila dekat sini dia dah start makin fall slowly balik to indicate that the complete dissociation of strong acid. Okay. So dekat sini sebab titrant kita dekat dalam burette tu acid, so dekat dia punya y-axis sini adalah volume acid added. So dekat sini ada equivalence point. So di sini adalah volume acid at equivalence point. Berapa volume acid ataupun base yang digunakan untuk capai equivalence point tu. So itu maksud dia. Okay. Alright. Now kita nak tengok the titration of strong acid and weak base. Contohnya macam hydrochloric acid and ammonia ataupun sulfuric acid and ammonia, nitric acid and ammonia. Okay. So sama juga untuk curve, untuk titration curve untuk strong acid weak base ada dua juga. Kalau untuk titrant, kalau weak base dia, kalau titrant dia weak base and unlike the strong acid. So maksudnya dekat conical flask tu adalah strong acid. And dia punya dalam burette adalah weak base. Okay, so dekat sini, okay, in this case, since analyte dia dekat dalam conical flask is a very strong acid, so dekat sini kita start dengan initial pH of strong acid kuat. Okay, so bila sampai dekat point sini, dia dah gradually increases, indicating that the weak base is now neutralized, indicating that the acid now is neutralized by the weak base added. Okay, so dekat sini dia dah capai equivalence point. So equivalence point dia pH less than 7. Okay, sebab dia strong acid kan dengan weak base. Okay, and bila dia sampai sini maksudnya the pH dekat sini dia dah capai what we call it maximum dissociation lah. Maksudnya dia dah habis, dia dah capai the end of titration. Okay, so dekat sini, so dia punya equivalence point dia pH less than 7, maybe around 3 to 6 macam tu. Okay, dia punya equivalence point. Okay, and this is the volume base at equivalent point. Maksudnya berapa volume of base required to reach the equivalence point. Okay, alright. Now, kita tengok kalau titrant dia pula sekarang strong acid, analyte dia weak base. Maksudnya yang dekat dalam conical flask is a weak base, dekat dalam burette is a strong acid. So bila maksudnya weak base ni, dia ni ada low pH. Okay, dia ada not really high pH lah, sebab patutnya strong base very high pH kan. Tapi weak base dia macam jatuh bawah sikit. Okay, so this is the initial pH of the weak base. If you draw the curve. Okay, bila you add the strong acid dekat dalam weak base. Okay, weak base tu kan lemah. Tiba-tiba kalau letak strong acid, terperanjat tak dia? Terperanjat. Macam tiba-tiba, aku kan pH tinggi kan sikit kan, weak base kan. Tiba-tiba ada strong acid masuk ke aku, macam terperanjat. Sebab tu ada sudden ataupun rapid fall of pH dekat sini. Maksudnya daripada dia ada high pH, letak je strong acid yang kuat tu, terus jatuh pH dia. Okay? Alright. So dekat sini bila dia jatuh tapi dia dah start jadi macam normal balik. Okay, throughout the titration process. Sampailah dekat equivalent point, dia dah start gradually fall, jatuh dekat sini, menunjukkan to indicate that now the acid is neutralizing the weak base. Okay, so dia akan dapat equivalence point less than 7. Okay. Okay, so now let's look for the titration curve between the weak acid and strong base titration. Contohnya between the acetic acid and sodium hydroxide, ataupun HCN and sodium hydroxide, ataupun HF and sodium hydroxide. Okay, so kita tengok kalau titrant dia, titrant yang kat dalam burette tu strong base, tapi analyte dalam conical flask tu weak acid. Okay, kita nak titrate strong base dalam weak acid. Apa jadi? Okay, awak tahu weak acid dia ada slightly higher pH than the strong acid, betul? Kalau strong acid dia kat bawah sikit, kan weak acid dia kat atas sikit lah, kan, betul? Okay, so this is the initial pH of the weak acid. So when you put drop the strong base inside the analyte, inside the weak acid, dia macam terkejut. Dia terkejut sebab tu ada start with rapid increase of pH. Okay, bila ada rapid increase of pH, okay, bila dah sampai sini dia dah consistent balik. So dekat sini dia dah increase gradually. Why? Maksudnya the base has gradually neutralized with the acid. Sampailah equivalence point dekat sini. Disebabkan strong base, okay, dia ada equivalence point larger than 7. Okay. Sampai dekat sini menunjukkan dia tak sampai end point, menunjukkan yang the titration process dah nak habis lah. Okay. Alright. Okay, last titration curve. Okay, kalau titrant dia, if the titrant yang dekat dalam burette is a weak acid and dekat dalam analyte conical flask is a strong base. Okay, so strong base has the initial pH yang sangat tinggi, betul? So we put it here. Okay, so this strong base, upon dropping the weak acid as a titrant, dia akan drop slowly. Okay. So now dia akan jatuh kat step sini. Okay, sampailah turun bawah dekat acid punya pH ni. Okay, so dekat sini equivalence point dia larger than 7. Strong base kan? Okay, larger than 7. Okay. Alright, and dekat sini sepatutnya the final pH of weak acid is slightly higher than usual lah. Kalau dia strong acid, dia sangat bawah kan. Lagi kuat acid dia. Okay. Alright. So this is how you draw the titration curve. So ada 6 titration curve. Okay, dia ada 3 jenis titration, tapi ada 6 jenis titration curve. Sebab apa? Titration dengan analyte dia berubah-ubah. So kita punya paksi kita pun berubah-ubah. Okay. Alright. So now, we are going to look at the calculation lah. Okay, so usually the question will ask you to sketch the titration curve and explain or show the variation of pH. Okay, so let's look at this question. Dia kata kat sini, an acid-base titration is carried out by adding 30 ml of 0.5 HCl dropwise into 25 ml of 0.5 sodium hydroxide. Calculate the pH of the solution. Okay. So sekarang ni yang kita maksudnya kat sini, HCl kita adalah titrate. Okay, and our analyte here is sodium hydroxide. Okay, so maksudnya ni dekat dalam conical flask, ini dekat dalam burette. Okay. So now, this is kita calculate pH of solution before the addition of HCl. Maksudnya, hanya semata-mata sodium hydroxide. So, kita nak tengok, so kita tahu, ini kita biasa tunjukkan lah, dia punya titration kan, punya proses. Okay, sepatutnya Miss buat dekat atas ni, tak apalah. Miss dah terbuat kat sini, so okay. Sepatutnya chemical equation ni before soalan. But it's okay. So before the addition of HCl, hanya ada sodium hydroxide. So maksudnya kita boleh kira pOH. Okay, supaya kita boleh kira pH dia. Okay, so kita boleh kira pOH sebab apa? Kita ada concentration of sodium hydroxide. As we know, strong base dia akan completely dissociate. So kita boleh assume yang the concentration of sodium hydroxide is equivalent to the concentration of hydroxide ion. So here kita boleh masukkan terus, okay, dia punya concentration of sodium hydroxide ni dalam nilai concentration hydroxide ion. So kita boleh dapat pOH is equal to negative log concentration OH minus. So equals to negative log 0.5. So equals to 0.3. So this is the pOH. Okay, to get the pH, we know that pH is plus dengan pOH equals to 14. So pH is equals to 14 minus 0.3. So you get the pH is 13.7, which is okay. This is like a very strong base punya pH, kan? Okay, and then so kita calculate pH at half of equivalence point. Okay, so awak tahu equivalence point is where the mole of acid is equals to the mole of a base. Okay, sekarang ni kita kena cari equivalence point. Maksudnya jumlah berapa volume of hydrochloric acid yang dah di-added untuk capai equivalence point. So kita kena, okay, so yang kita ada maklumat sekarang, kita ada maklumat molarity dengan volume of base yang kita boleh cari number of mole. So kita boleh cari number of mole of base here. So so when we find the number of mole of base using the MV over 1000, we got 0.0125 mole. So at half equivalence point maksudnya 1 over 2 lah. Kalau equivalence point 1 over 1 maksudnya sama. Okay, so kalau half equivalence point, half daripada equivalence point tu. So 1 over 2 times mole of sodium hydroxide. Okay, so kita akan dapat mole of HCl at half equivalence point 6.25 times 10 to the power of negative 3 mole. Okay, so this is how you got the mole of hydrochloric acid at half equivalence point. So now we can find the volume of hydrochloric acid added at half equivalence point. Okay, so bila kita dah cari mole of HCl, kita boleh cari volume guna number of mole divide by concentration. So, kita boleh dapat, kita masukkan number of mole yang dapat tadi and then kita divide dengan concentration of HCl. So, we got 0.0125 liter or 12.5 ml. Okay, excuse me. Alright. So, now we are going to do the table. So, this is not an ice table. Dia macam ice table tapi dia macam bukanlah kita guna initial change dengan final mole. Okay, so kita buat dia punya macam ice table. Chemical equation here. Okay, and now kita nak tengok. Okay, so, sebab kita nak kira pH dekat half equivalence point, maksudnya kita kena tahu concentration of hydroxide ion or hydrogen ion dalam the solution lepas capai half equivalence point. Okay, sekarang ni the initial mole dia adalah 6.25 times 10 to the power of negative 3 untuk HCl. Untuk sodium hydroxide kita ada 0.0125 mole. And produk tak ada lagi lah. Okay. So change dia dekat sini. Maksudnya kita nak pakai berapa jumlah HCl yang dah react, yang dah titrate dengan analyte base. Okay, so dekat sini kita kena tolak lah kan. So kita kena tolak 6.25 times 10 negative 3. And then sodium hydroxide pun kita kena tolak juga. Okay, so sekarang HCl kosong. And then kita akan dapat the sodium hydroxide punya final mole is 6.25 times 10 to the power of negative 3. And NaCl pun sama. Okay. So, now kita nak fokus kira concentration of kita nak kira pH of the solution at the equivalence point. So, kita kena cari. Okay, so maksudnya kita kena cari concentration of OH minus supaya kita boleh cari POH so that kita boleh cari pH. Betul? Okay, sebab ini acid analyte dia kan. Okay, so kita kena tengok yang ini. So, you tinggal yang ini je tinggal. Okay, kita akan tengok yang ini. Okay. Apa pasal aku lukis macam tu? Okay. So, kita kena tengok yang ini. Tengok yang ini. Okay, so kita kena kira concentration of now sekarang ni. So, now yang tinggal adalah 6.25 times 10 negative 3 mole. And then volume total. So, volume total ni adalah volume now. Okay, sebab analyte dekat dalam conical flask tu now kan. Volume now, sodium hydroxide. Plus dengan volume hydrochloric acid added at half equivalence point. Maksud tadi tu 12.5 ml. So kita akan dapat total volume is 37.5 ml. So kita akan divide, kita akan dapat concentration of now at equivalence point is 0.167 molar. Okay. Now, kita boleh cari POH. Sebab apa kita dah tahu concentration of sodium hydroxide at half equivalence point. So kita boleh assume yang dia punya yang hydroxide ion punya concentration sama dengan sodium hydroxide ion punya concentration final. So kita boleh dapat POH 0.8. So boleh dapat POH, bolehlah cari pH. So our pH now is 13.2 at half equivalence point. Okay? Right. Now, kita kena cari pH of solution at the equivalence point pula. So, dekat sini, at equivalence point, kita tahu the mole of hydrochloric acid is the same as the mole of sodium hydroxide. Okay, so maksudnya kita tak boleh pakai kedua-dua number of mole dalam pada kadar yang sama. So, we use the dissociation of water dekat sini untuk dapatkan pH dia. Okay, so dekat sini, pH dia, we know that the ionization or the dissociation of water will form hydrogen ion and hydroxide ion. So we know that the Kw is equals to concentration of H plus times concentration of OH minus equals to 1.0 times 10 negative 14. And we already know the concentration of H plus for this Kw is 1 times 10 to the power of negative 7. Okay, so now we can find the pH sebab kita dah tahu concentration H plus. So, we can find pH equals to 7. Okay, now, let's calculate the pH of the solution. after the addition of 30 ml HCl. So, dia dah macam sampai end point lah ni. So, first kita cari number of mole of HCl. So, when we find number mole of HCl, we find it 0.015 mole. And we got the mole of sodium hydroxide from the previous question where it is 0.0125 mole. Okay, now we're still doing this table, initial, change and final mole. Okay, and then we do the chemical equation here. Okay, so initially HCl has 0.015 mole and sodium hydroxide has 0.0125 mole. Okay, initially. Okay, so kita nak tengok change. So maksudnya berapa kita nak tolak kat sini? Nak tolak 0.15 ke? Tak, kita kena tolak berapa yang HCl ni react dengan now ni. So, tengok masa satu yang limiting reactant. So, now ni limiting reactant sebab dia paling sikit. So, kita akan tolak jumlah yang ni dengan yang ini. So, when we subtract minus 0.015 minus 0.0125, we got the final mole of HCl is 2.5 times 10 negative 3. Okay? And then we got the final concentration, final mole of NaO is 0 and final mole of NaCl is 0.0125. Okay, so now kita nak cari pH kan? So kita kena cari concentration of H+. Okay, so dekat sini yang ada final ni adalah HCl. So we find the new concentration of HCl is equals to NHCl divided by volume total. So, volume total here is equals to volume NaO plus volume of HCl added. So, yang berapa itu tadi HCl added? 30 ml. All of them. Okay, 30 ml. So, 25 ml plus 30 ml is equals to 55 ml or 0.055 liter. So, bila kita substitutekan dia punya value here, we got the concentration of HCl after the addition of the titration. After the addition of acid is 0.045 molar. Okay. Okay, now kita dah dapat concentration of HCl. And HCl is a strong acid. So, we can assume that the concentration of hydrogen gas is equals to HCl. So, pH equals to negative log H+. So, equals to negative log 0.045. Okay, and we got the pH is 1.3. Okay. So, this is how you find the pH. Okay. Alright, soalan akan banyak keluar macam ni. Okay. Alright, now we are going to need to sketch the titration curve to show the variation of pH against the volume of hydrochloric added. So, disebabkan yang dekat dalam conical flask tu adalah base, strong base. So, maksudnya dia akan mula dengan high pH. Betul? So, dekat sini, this is the initial pH of the strong base. Okay? So, gradually during the reaction, okay, the curves gradually fall. Okay, menunjukkan yang some of the base has been neutralized by the acid. Okay. So now, dekat sini is our equivalence point. Okay. So, this is our equivalence point. Okay, so this strong acid versus strong base, betul? Okay. So, bila strong acid, strong base, equivalence point dia 7. So, dekat sini di mana pH gradually decreases. Okay, sebab dia nak indicate that the concentration of hydrogen ion is in excess due to the complete dissociation of strong hydrochloric acid HCl. Okay, so dia dah turun bawah sini. Okay, dapat dah sini. So, tadi kita dah kira pH before addition, pH after addition, pH equivalence point. So, kan? So, kita label kat sini 13.7, 1.3. and then kita label the volume at which the titration is at equivalence point. So kat sini. Okay, when the pH is equal to 7. Macam mana Miss tahu volume equivalence dia 25? Sebab apa? Dekat half equivalence, HCl added is 12.1. Kalau full, maksudnya 12.5 times 2, 25 ml. Okay, and this is where it, bila capai 30 ml, the pH is 1.3. Okay, so this is how you sketch the titration. The titration curve. Okay, for this question. So, biasa soalan untuk titration, dia akan suruh awak jawab macam ni lah. Find pH solution before adding the titrate. When the at the half equivalence, sketch the titration curve. Okay, so this is how you do it. Okay, remember. Okay, so lastly, we are going to look at choose suitable indicator. Like how to choose a suitable indicator. So choose an indicator which the endpoint pH range lies on the steep part of the titration curve. Okay, and the pH range is also defined as the range over which the indicator change from acid color to base color or from base color to acid color. Depends lah apa kita punya analyte kan. Kalau kita punya analyte kita yang dekat dalam conical flask kita to base, so from base to acid color. Kalau kita punya analyte kita to acid, so from acid to base color. Betul? Okay, so this is the table lah for you to refer. Like contohnya biasanya types of titration kita ni, biasa endpoint range kita between ni, suitable indicator kita semua. So this is a type of indicator yang kita biasa pakai lah. Okay, alright. So that is all for the titration punya topic. Okay, it's very simple. What you need to know what is the titration process. You need to know the type of so you need to know the difference between endpoint and equivalence point. You need to know the titration curve ada 6 tapi jenis titration ada 3. And then you need to know how to explain the titration curve using you need to know the variation of pH, okay? And then you need to know how to calculate the pH at the different point, dekat half equivalence point, dekat endpoint, so kena tahu. Okay. And you need to know how to choose the suitable indicator. Alright. So actually that is all for this 7.2. Okay, so we are going to continue with our 7.3 next week. Okay, and the tutorial for this 7.2, okay, you can try do it by yourself. Okay, Miss akan upload video calculation semua lepas ni. Okay, alright. So try buat dulu. Okay, sebab soalan tutorial for chapter 7.2 is quite easy lah. Okay, sebab apa? Semua benda Miss dah explain kat sini. Okay, but I will discuss. Okay, I will make a tutorial video solely for tutorial discussion. So this video is only for explanation for 7.2. Okay, so that is all for today's tutorial. So bye bye. Assalamualaikum warahmatullahi wabarakatuh.